Hello viewers, welcome to UNC Digital class. In today's class, I am going to discuss about stack in data structure. Okay, as we have already discussed about stack at the time of classification of data structure. So stack means what? It is a linear data structure in which data are inserted and deleted at one end based on the principle of LIFO, that is last in and first out. Okay, let's see stack in data structure. So in today's class, we will be discuss on introduction to stack. What are the basic operation we will perform over the stack, array implementation of stack by using push operation, and we will display the stack and the array implementation of stack of the pop operation. Okay, let's see the introduction to stack. So as I have told you already that stack is a linear data structure, that means data are stored sequentially in stack and which follows a particular order. Okay, that means that is as it is a linear data structure, so it follows a particular order in which operation are performed in LIFO principle, that is last in first out. Okay, so in real world, stack allows operation at one end only. That means we will insert the data element into the stack at one end, and at the same end we will be remove the element from the stack. For example, in real world we can place or remove card or plates from the top of the stack only. Okay, so this is the pictorial representation of stack. You can see here we are inserting the element, and the element which was inserted at the last into the stack, that will be removed first from the stack. You will see here this element is inserted last into the stack, and the same element is removed from the stack first. So it is based on the principle that is last in and first out. And whenever we want to insert the element into the stack, that operation is called as the push operation. And when we remove the element from the stack, that operation is called as the pop operation. Okay. Then next we will see what is the basic operation we can perform over a stack. The stack operation may involve initializing the stack using it and also deinitializing it. That means we may insert into the stack and we may remove the element from the stack. For initializing the stack and deinitializing the stack follow two primary operations, that is push operations and pop operations over the stack. So push operation means we have to pushing an element onto the stack, that we have already see here. You can see here we want to push an element. So this, when we insert the element into one stack, that operation is called as the push, and when we remove the element from the stack, that operation is called as the pop operation. Okay, or ultimately we can say inserting an element means push an element into the stack, and removing an element, that means accessing an element from the stack, is known as the pop operation. Okay, so we can implement this stack by using two different methods, that is array implementation of stack and linked list implementation of stack. So in this class we will discuss the array implementation of stack, and first we will see the array implementation of stack push operations. Okay, that means the process of putting a new data element into stack is known as push operation, as we have already discussed, and the push operation involves a series of steps. That means these are the steps, and using these steps we can insert an element into the stack. So in step 1, you can see check if the stack is full or empty. Okay, so in step 1 we will be check the stack is full or empty. Then if the stack is empty, then now we can insert the element into the stack. So in step 2, if the stack is full, then produce an error and exit the stack. That means if the stack is full, then we can't insert a new element into the stack. But if the stack is empty, that means now some memory space are available in stack and we will be able to insert an element into the stack, then we will go for step 3. Okay, if the stack is not full, increment the top to the point of the next empty space. So top is what? Top is the pointer, or you can say variable, which is point the current location of the stack where we want to insert an element. Okay, so if the stack is not full, then increment the top to point the next empty space. Okay. And in step 4, add the data element to the stack location where top is pointing and then return to the success. You can see here the empty space which is pointed by the variable top, and in that location we will be insert the element E into the stack. So after insertion of the element E, the stack became like this. Here you can see the element E is inserted, and that means one push operation is performed over the stack. So this is the different steps of inserting an element into the stack. And for algorithm and for function implementation, we will see what is the array implementation for push operation. So in push operation, we will take 4 arguments, that is the stack, that is the array, and top is the variable which will store the current location or which will point the current location of the stack. Then next, what is the maximum size of the stack, that means what is the maximum size of the array, and the item which is to be inserted. So in step 1, as per our discussion of number of steps, in step 1 we will first check if the stack is already full or empty. Okay, if the stack is already full, that means now top is at the maximum size of the array. Okay, that means now top point to the maximum size of the array. Then print the stack is overflow. It means what? Now we are at the end of the stack and no element is to be inserted into the stack. The stack is already full and the top is at the maximum size of the stack. Now we will return. Okay, if the stack is already full. If the stack is not already full, that means now some space is available for the insertion of new element, then we will go to step 2 for the increment of the top variable. Okay, set top equals to top plus 1. When top is incremented, then top points to the next empty space at the stack, and where the top is pointed at that location, we will be inserted the new item. So in step 3 we will perform the insertion operation. That means stack of top. Here stack is the name of the array. Here the stack of the top will be stored by the item. So this is the algorithm statement to insert a new element into the stack. In step 4, now we perform the return statement and we will be returned to the calling part. Okay, this is the algorithm for push operation, and this is the function implementation of the algorithm. And in function implementation, here we declare the stack array as globally. That's why here we are receiving only the element which is to be inserted. The maximum size and the array of the stack array is declared as globally. That's why we are here receiving the element which is to be inserted. Suppose that element is stored in the variable x. So as per our discussion, first we will be check that the stack is already full or not. That means the top is now point to the maximum size of the array or not. So for that we will be execute a statement, that is if top greater than equals to n minus 1. That means the array size is n and we can store maximum n minus 1 number of elements. So if the top value is greater than equals to size minus 1, that means now the stack is overflow. So we will give a message that printf stack is overflow. Then comes to else part. That means if this condition is false, that means if top is not greater than equals to size minus 1, this condition is false. It means now some space is available in the stack for the insertion of new element, and we will go from if statement to else part. Okay. So as per our discussion, so for insertion of the element, the top must point to the empty place of the stack. For pointing the empty place, we must increment the top counter variable value, that is top equals to top plus 1, that is top plus plus. When we execute this statement, so top will be point to its next empty place, and we will store the element at that location by executing stack of top equals to x. Okay, then end of the else curly braces and end of the function block. So in this way, we will call the push function every time when we want to insert the element into the array or when we want to perform a push operation into the stack. So next we will see how we can display the element into the from the stack. Okay, this is the function. By executing this function, we can also display the elements those are present into the stack. So this is the function display function, and in this case we also declare all the variables globally, that is the stack, array, top element and the variable counter variable I all are declared as globally. So simply call the function void display, and first we will be check if top is greater than equals to 0. If top is greater than equals to 0, then now we will be display the element those are present in the stack. So initialize for I equals to stop. Okay, for I equals to top means whatever with the value contained by the stack, that index will be pointed by the top variable. So now you want to display the data those are present in the stack. So based on the principle of LIFO, we will be display the last element first and the first element at last. So for displaying the last element first, we will be initialize the loop counter variable to top. Okay, so I equals to top. Okay, then we will continue our loop until we extract all the element from the stack. So for that we will be write the condition, that is I greater than equals to 0. That means we will move to the lower index of the array, that is 0. For that's why here I am writing I greater than equals to 0. As we are displaying the element from the top of the stack, that is from the maximum size of the array, so we will be decrement the counter variable, that is I equals to I minus 1. If this condition is false, okay, that means now the stack is empty. If top is not greater than equals to 0, that means the top is not greater than 0, not equals to 0. That means still we are not inputting any data or we are not inserting any data into the stack. It means the stack is empty. So we will be execute the else part and we will print a message that the stack is empty. Okay. So this is the function implementation to display the elements those are present into the stack. Okay. So next we will see the pop operation. That means we remove the elements from the stack. That is known as the pop operation. That means accessing the content while removing it from the stack is known as the pop operation. Okay. Pop operation involves the following steps. That is, first, as like push operation, in push operation we will check that the stack is full or not. That means the stack is overflow or not. So in case of pop operation, we will be check the stack is underflow or not. That means we will check if the stack is empty, then nothing is to be displayed. So first we will be check the stack is empty or it contains some data to pop. Okay. Then comes to step 2. In step 2, if the stack is empty, then produce an error and exit from the procedures. Okay. If this condition is false, that means if stack empty condition is false, then some element must be, at least one element must present into the stack, and we will be pop that element or we will remove that element from the stack. Then comes to step 3. If the stack is not empty, access the data element at which the top is pointing. So currently top will point at the location where the element is inserted. Okay, and from that location we will be remove that element by executing the pop operation, and after removing that element from the stack or by executing pop operation, then we will decrease the top variable by 1 because we are removing the element. In case of push operation, we will increment the top variable for finding the empty location into the stack. But in case of pop operation, we will decrease the value of top for removing the next element from the stack. After decreasing the top variable value by 1, then return and success of the procedure. So this is the pictorial representation of the pop operation. You can see first top point, the current location where the top point, that element will be first removed from the stack, and when we remove E from the stack became like this and top point to the next element which is to be removed from the stack. So in this way we can remove the D. After removing D, top will point to the C element. Then after removing C, top point to B element. Then again after removing B, top point to A element. And when we remove all the element from the stack, the top will point to the last of the stack, stack. That means at the underflow situation, at this location, top becomes -1. And when top became -1, then the stack is in underflow situation. Okay. Let's see the array implementation of pop operation. That means what will be the algorithm for pop operation and what will the function implementation for pop operations. Okay. So in pop operation, we will receive the array, that is stack, and first step will be check if the stack is already empty, that means nothing to be displayed. That means at that location the value of the top is -1, that I have already told you. Then we will be display a message that is stack is underflow and we will be return and end it. Okay. If top is not -1, that means top has some value, then we see that there must be an element in stack and we can perform pop operation over the stack. Okay. Then come, if this condition is false, that means in step 1, if top equals to -1, this condition is false, then we will go for step 2. That is, we will be remove the element from the stack. Okay. The element will be stored in the variable item. That means currently the top point to the location and that element will be removed. That is, stack of the top element will be removed and stored in the variable item. Okay. And in step 3, we will decrement the top variable because we are performing the pop operation. That is, top equals to top -1. And we will lastly in step 4 will be return function. Okay. This is the algorithm to implement the pop operation in stack. Okay. Then comes to function implementation of stack operation. In function implementation, here you can see, here we declare the array, the stack array as globally. So nothing to be received. So void pop, and we will first check that the stack is in underflow situation or still the stack contain any element to pop. So for that we will be check if top is less than equals to -1. Okay. If this condition is true, then the stack is in underflow. We will be give a message, that means we will print a message that is the stack is underflow. If this condition is false, then comes to else part, we will be pop the element, give a message, the popped element is %d, that is stack of stop. That means currently the top point to the location of the stack, that element will be popped and print through the printf function, that is the popped element is %d and the stack of tops. That means now we will next decrement the top variable for removing the next element from the stack, that is top equals to top -1, top -1, or you can write top minus. Okay. When you write top minus, then it will decrement the top variable and the top will point to the next element which will be popped. Okay, or which will be removed from the stack. So in this way, for removing element from the stack, every time we will call the pop function to remove the element from the stack. Okay. And this is all about your algorithm implementation for pop operation and function implementation of pop operation. Okay. This is all about your stack and the push and pop operation in stack, and how can we implement the push and pop operation in stack by using array implementations. In next class, we will be implement the stack by using the linked list. Till then, keep watching. Thank you.